Hi students, good morning and welcome once again in ELE 3013 Electronics 2 Laboratory. And today's lab is all about laboratory number 6 entitled Integrator Differentiator. Okay, so let us get started. Okay. So the main objective of this experiment is to examine the rate of change of output voltage and frequency range validity of an integrator circuit. Okay. Second, predict and record integrator output for a square wave input. Okay. Third, examine the rate of change of output voltage and frequency range validity for a differentiator circuit. Okay. And last objective is to predict and record differentiator output for a triangular wave input. All right. So materials used in this experiment, you will be needing a 1 IC LM741 op operation amplifier. This one. Okay. This is the op-amp 741. A function generator. Okay. That is built in our trainer. And we have you need also a power supply, the plus minus positive minus or negative 15 volts. And you need resistors, okay, a bunch of resistors, the 2.2 kilo ohm, 22 kilo ohm, 10 kilo ohm, and 100 kilo ohm. And you need a capacitance, a 4.7 nanofarad and 2.2 nanofarad. Okay, so as I have said, you need a capacitor that is 4.7 microfarad. So this is the one. Okay, 4.7. It is, I cannot see, you know. Let's see. Let's focus it a little bit. Okay, this is 472. Okay, the code is 472 for this capacitor, 472. And okay, and this capacitor, the other one is 222. Okay, all right. Now, let us start connecting the integrator. Okay.
Hi students, good morning. My name is Michael. I have
All right, so we're going to connect first the integrator. Okay, so you need an IC LM741. So I already connected here. So maybe some of you in your trainer, I already connected it. Okay, and you need a 100 kilo ohm. Okay, so let us get a 100 kilo ohm from this. Okay, so 100 kilo ohm. So you can find it here. Here, 100 kilo ohm. Okay, so this is 100 kilo ohm. All right, and this 100 kilo ohm is connected to number 2 to number 6. Okay, so pin number 2 and pin number 6. Okay, connect them together just like that. Okay, and you need a 10 kilo ohm also, 10 kilo ohm, and this 10 kilo ohm connected also to number 2. Okay, to number 2. So I'm going to connect it here, number 2, and this point. Okay. All right, and a connection between the function generator and the input, no? Okay, so from the function generator output, connect it to the 10 kilo ohm, no? Here, 10 kilo ohm. All right, then you need another 10 kilo ohm resistor that is connected to number 3 going to ground. Okay, so number 3. So 1, 2, 3 is the one, and it will be connected to the ground. Okay, so you need a wire like that. Okay, like that, no? To the ground. Like this. Okay? Okay, so I think we need more wires to do it, okay? Okay, now after that, after that, so you need a power supply, no? So positive 15 going to number 7. So 6, 7 to positive 15. Okay, and the other one, negative 15 to number 4. So from here, number 4, connect it to negative 15. Okay. Okay, just like that. Okay. All right, and a 2.2 nanofarad, no? Between 2 and 6. Okay? Between 2 and 6. So I better you put it here, no? Somewhere here. Like that. No? Sorry for that. Okay. Oh, it's difficult. Like that, no? Okay, and get 2 wires. No, get additional 2 wires. Okay, so I'm gonna get a additional 2 wires. So these 2 wires will serve as a connection of the capacitor between the here here, this leg, and this one, then that's the other leg. Okay, one will be connected to number 6. Okay, and one will be connected to number 2, like that. Okay. All right. So there you have it. No, this is the connection. No, and of course, no, you need this one. No, the BNC to BNC to alligator. No, channel 1 and channel 2. So channel 2 will be your output. Okay, so this black color will be negative, and this one will be connected to the here, no, number 6. Okay, and the other one, the channel 1 will be connected to the ground. No, the black will be ground, and the red will be here in the input. Okay, in the 10 kilo ohm. Okay, so there you have it, no? So let us switch it on. Okay, so set a square wave. So the square wave, put the function generator to square wave. Okay, all right, with the frequency of 10 kilohertz. Okay, I'm gonna put this one in 10K. Okay, and 10 volts peak to peak. Okay, so all right. Okay, let's try to switch on. Then this one should be in maximum. Switch on. Okay, and let us see what will be the output. No. Okay, gonna do like this so that you can see the function generator. I mean the oscilloscope properly, right? Okay, so now I put the measurement time frequency so that I can see the frequency. Okay, sorry for that. Okay, now please remember that you need to put a ground, no, from this, okay, to the ground here. Okay, so don't forget about it, no, because if you forget it, and you will get a wrong output, okay, or wrong readings. Okay, all right, so now this is the output, no, of our integrator. circuit. Okay? So record all the parameters. So make sure that the frequency of the input, no, that is in yellow, that will be on 10 kilohertz, approximately 10 kilohertz. Okay? And our B peak to peak is 10 volts. Okay? All right? So 10 volts peak to peak, and frequency is 10 kilohertz for the input. Okay? And our output, no, as you can see here, the reading, the output B peak to peak is 10 volt as well. And the frequency is 10 kilohertz. Okay? For the output. All right? So that is our differentiator. Okay? Integrator. All right? Okay? Next thing you need to do, we're going to make a circuit for differentiator. All right? So take note of this, and we will do now the differentiator. Okay, now let us go now to the differentiator circuit. All right? So, of course, no, in differentiator circuit, you also need a 741, no, operation amplifier IC. Okay, so we already connected this to the breadboard. Okay, and next thing you need to do is to locate for the 22 kilo ohm, no, from the resistor. So where's the 22 kilo ohm? So here it is. So you need one 22 kilo ohm. Okay, that is red, orange. So this 22 kilo ohm, connect it to number 2 to number 6. Okay, so here from number 2, connect it to number 6. Okay, and after that, you need a 4.7. Okay, 4.7, no, this one, no, capacitor. Connect it also to number 2. Okay, so I'm gonna connect it like this. Okay, like this, no, number 2. Okay, and then a 2.2 kilo ohm. So look for 2.2 kilo ohm. So there it is, red. So from the capacitor, no, from here, capacitor, like that, connect it, and through here to this point. Okay, and number 3, no, number 3 will be directly connected to the ground. So 1, 2, 3, connect it to the ground, like that. Okay, and you need an output also, no, from the function generator. Connect it to here, no, to the 2.2 kilo ohm resistor. Okay, all right, and then you need a power supply. So at number 7, so this is 6, 7, make it to the positive, 15, and number 4, negative 15, no? So this is number 4 to negative 15 here. Okay? All right, and then you need a channel 1, no? Channel 1, connect it this black wire to the ground and the red to the input. All right, and don't forget to also connect a ground, no, from here. Otherwise it will not give you the correct output. Okay, and channel 2 will be connected to the output, number 6, and ground, like that. Okay, all right, and this one should be in full. Okay, and this time you're going to give 7 volts peak to peak. So switch it on. All right, okay, so this is the output, no, of your differentiator, no. So frequency should be 400 hertz. Okay, adjust the frequency to 400 hertz. Okay, This time you need a triangular wave input, no? Triangular wave, okay? So make sure the function, no, the function in the function generator, change it to triangular wave, no? In integrator, we use square wave as input. This time we use triangular wave as input for the differentiator. Okay, and 400, no? 400 hertz, no? Input. Okay, approximately like that. And the peak to peak, 7 volts peak to peak. Okay, right? Let's auto set. All right. Okay, so just a little bit. Okay, all right. So this is your input, the triangular wave, and this is your output. It's like a square wave, no? Not exactly perfect square wave, but at least, no, you got this square wave. All right, so measure the output voltage. The output voltage will be here, no? So B peak to peak, that is 1.36 volts. All right, so it's very small. Okay. All right, and that's it, no? That is your laboratory number 6, integrator and differentiator. All right, thank you and good luck.